This is the exercise for exploring pre-trained embeddings. So the code we will work on today showcases the use of pre-trained word embeddings to represent words as vectors in a high-dimensional space. So let's jump on our first line of code. Let's understand what are we trying to do over here. So this line of code over here, what it will do is it will download and load the pre-trained word embeddings from the Globe model, specifically the Globe Wiki Gigaword 100 variant, the Wiki embed variable right over here. Wiki embed variable will hold the loaded word embeddings. The word vectors in this model have a length of 100. So once this is done, we will try to print it. So what we will do is, as you can see over here, this line prints the length of the word vector corresponding to the word king. It demonstrates that word vector has a length of 100. And moving down, so what is happening over here is wiki embed king syntax retrieves the word vector associated with the word king from the wiki embed object, which contains the loaded pre-trained embeddings. The word vector is a 100-dimensional vector that represents the semantic and syntactic information of the word king in the embedding space. And king over here simply prints the value of king variable. So the word vector is a 100-dimensional vector, that's why we can see 100 over here. And this is the array king, which is printed right over. Let's move on to our next line of codes. So try to understand what's going on over here. So this line finds and prints the words most similar to a king based on the trained word vectors. It uses the pre-trained embeddings to compute the similarity between word vectors and provides a list of similar words. So thus, most similar method right over here returns a list of tuples where each tuple contains a word and its similarity score with respect to word king. So we can see over here prince with its similarity code, queen with its similarity code, brother, monarch, right? Let's see what's going on down over here. So on with these two lines of code, what we are trying to do is we are trying to retrieve word vector for the word queen and apple from the pre-trained embeddings stored in wiki embed object. So once that is done, what we will do is we will just create three lists over here: king, queen, apple, containing word vectors for king, queen, and apple respectively. So they are reshaped as 2D arrays or nested lists, as it is often necessary when calculating cosine similarity using libraries like scikit-learn, which expect input vectors to be in a specific format. So the vectors are wrapped inside square brackets, as you can see over here, to create a single item list. Now let's have a look at how we can calculate cosine similarity. So by calculating cosine similarity, we can measure the similarity between different words based on their vector representations. So as we can have a look over here, cosine similarity function is used. So let's see what's this line of code doing. So it's calculating cosine similarity between the word vectors S1, which stores the similarity between king and queen, and S2, which stores the similarity between king and apple. So this function computes cosine of angle between vectors and returns a value ranging from -1 to 1. So these results are printed on the console with the help of these two lines, as you can see over here. So this is how, in conclusion, what we are trying to do is by calculating the cosine similarity between different word vectors, we can quantitatively measure the similarity between words in the embedding space. So this measure in particular it is useful for tasks like word analogy, word clustering, and similarity-based search.